Okay, so let's do the rest of muscle tissue. This is a load and speed of contraction table. It's mostly an inverse relationship. That means when, if you're bench pressing 5 pounds, you can rep it like 50 times in a minute, right? But let's say that instead of 5 pounds that you're pushing on the bench, you're pushing 500. Let's say that you can do 500. So you're pushing 500 and you can only get out 1 or 2 reps within a minute. So as the load goes up, right, as the weight increases, the speed goes down. That's an inverse relationship. As one goes up, the other one goes down. So it's this kind of relationship. So if I say this is your load, you can call it load, you can call it weight, you can say we can just keep it as load and weight. This one is speed. You can also call it velocity. Speed and velocity are pretty much the same thing. The only difference is if you're taking physics, speed is what we call a scalar. That means it doesn't have any direction. It has magnitude. But velocity has both magnitude and direction, so they call it a vector. So scalar, vector, and in the letters themselves, they kind of tell you. I won't test on that. That's just for clarity. So as the load increases, the speed decreases, right? How fast you can actually push it within 1 minute decreases. But as the weight or load decreases from 500 pounds to maybe 5 pounds, right? The speed with which you can move it within 1 minute goes up. So they're what we call an inverse relationship. So a lot of times you might see this relationship where L is inversely proportional to S. That means there's an opposite relationship here. So here we go. You guys can read through that. ATP production. So this one we're going to keep it really simple. If I'm looking at a 1 rep max on a bench press versus a sprint versus a marathon, we're going to keep it to those 3 extremes. 1 rep max only takes you a second, if not a few seconds, depending on